Tradecraft by a gentleman named Alexander Rymdeko-Harvey. Is your second year here or third year?
Second year here.
Second year at BSides. Last year I remember you gave a great talk on advertising pro. Going off memory now, so help me out. Soldier, you were stationed here for a couple of years.
Yep.
And then he was stolen away by Ferris Group. Ferris Group is another just incredible sponsor that has helped BSides Security Conference every single year. They send out some great speakers every single year. They help us financially every single year. So Ferris Group, they've got their Adaptive Threat position where they do some incredible research. They've released several tools that have made my life as a penetration tester much, much easier, from the Veil framework to PowerShoy to Empire, PowerShell Empire. How awesome is that? Right? Thanks, man. I love you. So please join me in welcoming Mr. Alexander Rymdeko.
Thank you. How do you get it switched over? Mark, which one do I have to hit to switch over?
Oh, yeah, you want your slides up?
Yeah, it'd be kind of helpful.
Okay.
We can go off that. That's fine.
You can just talk to the sponsors.
So like he mentioned before, the talk will be on repurposing adversarial tradecraft, and as he said before, I've been here last year actually giving a talk, and I'm really happy. I want to thank Mark first, but just by letting me come back and giving me this opportunity to come back and see all the guys and friends, especially in the Augusta community. So it's really nice. We'll kick it off. I do not have a clicker, so hopefully, once I click in there, we'll be good. So, a little bit of introduction and overview over the talk. Who am I? Where I come from? What's my background? What are we going to be talking about? What are these TTP things? And eventually get into the adversaries that we're actually going to cover and go over. So in this case, we'll just kick it off by just a little introduction of myself. As he said, my name is ridiculously long, Alexander Rymdeko-Harvey. My parents absolutely hated me, so they gave me that name. I was just recently, last day of the Ferris Group was actually Friday. I was a pen tester and red teamer with them on the ATD team, and there's actually some guys here. But I'll be making a huge move over onto the Sony side to help them push forward their red team capability on their Sony's global threat emulation team. So I'm really excited. As you mentioned before, previous soldier. So for all those that are serving still, really thank you, and let's get started. So some background on the development. This is obviously an extremely tool-centric talk. Just as the title states. It's based on taking adversarial TTPs and somehow emulating them in our red team tradecraft. So in this case, where I came from, a heavy background in Python, a lot of these tools are actually a very low level, so they're going to be written in C++, and that's low enough level for me since I learned C++ about 6 months ago. So hopefully the tools are solid, they all run, they all work, but there's definitely room for improvement, so if somebody wants to contribute, push, some changes and stuff like that, help me clean up code, it'd be highly appreciated. And second, I was obviously with a team, ATD, and a couple buddies of mine, and they're all listed down there, but they went through hell trying to help me get this set up, because there's a lot of complicated stuff in here, and a lot of techniques that I had no idea how to start or even get an entry point into building some of these techniques. So, what is RAT? It's kind of a tricky name or sly name for repurposing adversarial tradecraft. And it stems from their traditional view of what red teaming all stems back to wargaming eventually. It's basically taking your force, looking at the enemies, repurposing what they're doing, and eventually advancing your tradecraft, or from like a DoD standpoint, elevating your capability as a fighting force. So as red teamers, we have to do this consistently. The enemy or nation state X or whatever group is out there of malware authors have a lot more time, dedication, and resources than you will have in 2 weeks to sit on a pen test or a red team and achieve the same amount of coverage as they will. So why is this really important? One, it pushes the community forward. And most importantly, you can educate yourself so that you can educate your client and also bring the newest attack angle to your tradecraft. So a little quote, red teamers often differentiate themselves from pen testers in that they emulate adversaries, yet how often do we hear them talk about actual adversarial TTPs based off of real-world threat intel? That quote was from me, by the way. So, is that illegal to quote yourself? I don't know. But anyway, so this is actually something that's like talked about quite often in the red teaming space. Is that how often do you, like, as a red teamer or a pen tester, do you have enough time to sit down and dig into like a threat intel report and actually go out and build those capabilities that probably won't even potentially help you on your test? And that's something that we'll cover. And you have to make that decision as a tester to decide if that is worthwhile in pursuing. So like I said before, I'd kind of jumped over it, taking time to analyze reports. Some of us kind of like hate on the threat intel side, and some say it's like boring or whatnot, but it does play its like role in developing these TTPs. So like the Dooku reports and the stuff that Kaspersky puts out, like the technical reports, are actually pretty extremely detailed for what they are, and you wouldn't be able to replicate some of this without it, to be honest. So the first threat we're going to cover, Dooku. It's probably one of my favorite like malware families. They have like tons of tricks up their sleeve, and we're going to cover over some of the stuff that they kind of like focus on. One of the interesting things is, for being such a like early threat actor in our space, like they always say like the red teaming and pen testing is about 5 years behind, and it's like totally possibly true. Like WMI data collection, these guys were doing like remote registry collection with WMI before we were even thinking about using WMI like offensively. So these guys were on the cutting edge. They had labeled as an APT for a reason. They have the ability to have those resources to devote to this type of collection operations. Something really interesting about them is their network leveraging. Something as a red teamer that I found out very early on in the beginning was that while you have all these capabilities as a pen tester to sit in a network, plug in, and just rock their network with Responder, that's not the same, or it's not even near true when it comes to trying to do that on a red team engagement. Things like Inve and stuff like that had made it a lot easier over the years with PowerShell, but trying to do that natively before PowerShell, you would literally have to roll in a complete custom application. So that was complicated. And they do that. They use WPAD. So APTX may have ODay to DA immediately, but why use that when the shortest path of resistance is just to use a WPAD and not burn their potential ODay? So it's kind of interesting to see like this type of attacks being played out, even though we're still using them in a pen testing role. Interestingly enough, tons of driver management. They have the ability to start, stop, and we'll cover that actually. This is one of the things we're going to be covering. And persistence. So I'll show you a quote next on the next slide about persistence. But one of the things that make them really unique is that they had the, I guess you could say, confidence that they didn't have to worry about implanting on a machine or server, because they knew exactly where they were going to be inside a network and how to stay there long term. They could just stay in memory and not worry about the reboots or whether it be a, they're not going to be sitting on your average user desktop. They're going to be sitting in like a server rack somewhere where redundancy is in play for power and all those type of things. So that kind of shows you some of their TTPs, and that's something that we can definitely replicate easily in our everyday life. Situational awareness, and we'll cover this a little bit later as well. The text running sniffers, stuff like that. So they had an idea that they knew that they potentially could get caught, and they're going to keep an eye out for some basic situational awareness checks. And of course, AD query. They were parsing ADSI and the JC enumeration to like a human readable XML format, and that's kind of what we've been doing with PowerView on like our team is heavy PowerShell based. Well, the team I was just on was at ATD was very heavy PowerShell based. So it's really kind of cool to see like adversaries using those same exact techniques and to think that you're doing the same kind of like emulation as them. So the first thing, as you can see, this is like from the hacking team dump. The guy basically said like, hey, I always use Dooku 2 style persistence. And it's kind of true. About like, I don't know, 2 years ago, staying in memory was tough. A lot of exploits, like, you generally drop the disk. You would almost always, if you were going to lay in some type of persistence, you would use some type of like one of the million ways to like persist on a Windows environment, whether it be registry keys or whatever. So I wanted to like take this type of TTP that they developed, and how can I go ahead and port it over onto my side that's like feasible. One, they did in memory. Two, we talked about the location. So this dictated like the survivability of the agent and basically where they'd want to implant. And third, if you're in memory, it's a lot easier to avoid hips and things of those sort that would, but like if you're dropping, let's say, a binary disk or something of the sort, you have a higher risk of getting caught. So all those things kind of combined into a package of that I knew that I could possibly go after this. The driver for this was I had a few long-term ops that were like 30 days plus, which is really unique in the red teaming side, because usually you only have like 3 weeks, and that's pretty much the longest you're going to get. That's maybe with some outbrief time too. And I knew that like if I were to do this, I would have the capability of maintaining long-term C2 out of a network. And so this tool was actually built, and I'm going to show it to you guys, but this one actually came in handy. So that's kind of cool to actually see something you built and have it be used. Excuse me. So some questions you have to ask yourself. I kind of broke it into 4 different locations of how, or 4 different segments of how I'd like to analyze the situation. 1, the target location. 2, the system environment. Hardware platform and operating system. When I say target location, I'm talking, is it a data center? Is it like a backup power supply? Those type of things. Is it hardware? Is it virtualized, or is it a system enclosure? Is it in a rack server? All those things we can query with WMI, which turns out to be extremely useful. And then system environment, things that you would like right off the top of your head, like the latest boot time. Like I want to obviously persist on the box that has the lowest or the oldest boot time. And then operating system, Windows OS, enterprise server, stuff like that. So I attacked this from a few different angles. I knew it had to be PowerShell, so this is kind of like the layout of it. And I know I needed to be able to target specific OUs in a network. So in this case, I used PowerView's GetNet Computer, and I was able to basically use that as my starting point to target specific net, like server OUs, stuff of that sort. Then I could basically check to see if the box is up, obtain all the WMI objects that I needed for properties, and then calculate values, do a standard deviation weight calculation off it, and then build statistics to see and like visually represent like a network segment for me to pick my location. So it's kind of like every other standard PowerShell script out there. Has threading built in, so script blocking, all that kind of stuff, which makes it quite usable, because obviously querying, like, I don't know, if you're in a network 20,000 computers, I wouldn't suggest running this, but you could, I guess. And as I talked about before, this is just some tips for like finding a custom OU for servers or something of the sort. And that came out to be really helpful, this bottom one with the LDAP query. So that was helping me find like Windows 2008 servers. So as I mentioned before, I had a few different sections that I wanted to like go after and attack. And I had to build like basically a persistent survivability rating, which is pretty cheesy sounding. But I basically I knew I had to have like a couple of different properties, and they had to be weighted. Because just because you have a low boot time doesn't mean necessarily I want to sit there and live there. Things that like 10% would be the WMI system enclosure. I feel like that's quite important versus, the WMI OS class. So I took those, calculated the huge weighted value of them, and was able to build basically a statistic off of each individual computer object. And then I could pass that to a VM check and a desktop check, and I could like split apart the network that way. So I could say, okay, maybe I want to persist on the desktop side versus server side, or if I want to persist on VMs versus servers. So in certain cases, this is like completely my version of what I feel is important. There's no like rhyme or reason specifically for those numbers, except for I felt like those were the values that they should be assigned. So, as I talked about before, just some basic calculations, calculating the standard deviation and calculating the variance. The reason why I use the standard deviation is it gives me a good idea. If you know like how the standard deviation goes, you basically have an average like baseline in your network. So all these computers that are like, let's say out of 500, restart like every day. And that would be like a certain rating. And I can basically pipe that in, do a calculate on the variance, and then find myself locations in the network which have higher like outside of those standard deviation zones, and those can find me spots where, like, okay, maybe this computer is not part of the GPO policy that restarts every night. And I just actually put together a quick demo, just for time's sake here, so we can go ahead and play that fast. So I'm just running through some like the basic commands. I'm sorry, I have like, excuse me. So I basically set it up to like max host 2. I have a small domain. As you can see, it builds all the objects, passes it through the pipeline, like so you could do like raw data processing with it, like off the pipeline in PowerShell, which is really nice. And then I basically build those values, and then I calculate the survivability mean. So those are like 3.23. There's not much deviation in these boxes, but you could see that they were detected as Windows. Those were detected as VMs and that sort. So that kind of was really helpful for me. In large data sets, this becomes extremely important because querying 500 boxes by hand on a server, like in a server like OU, would be really complicated. So this makes really easy use of it. Okay. Or not. That's not good. Whoops. The second thing we talked about, network leveraging. So, like I talked about before, they did use network leveraging for their attacks. So why couldn't we as pen testers or red teamers? And I knew that one thing that made Dooku and a lot of these like advanced pieces of malware extremely unique is their modular build. They have the ability to load up modules and then run those specific modules in certain locations. That's why if you ever read like some of these some of the high-level technical reports, they generally ask people or they reach out to the community like, hey, if anybody has seen other modules in these IOCs, please hit me up so I can analyze them. And they definitely have modules for different attack platforms, AD, query, all that kind of stuff. So that was really unique to it, and a lot of these were modules inside of Dooku's platform. And also the sniffer portion. Something that I thought was really cool was that they had the ability to do like PCAP capture and network alteration on the target host, which usually requires like a kernel driver, things of this sort. And this will kind of lead us into this next section of network leverage. But and those types of drivers allow you to do some of the remote injections, packet manipulations, stuff that you generally can't do like on a Windows operating system without the kernel space execution. So there's two options. You either have user mode. In our case, we're actually going to go over both. I'm going to cover user mode capture, so using Wsa 2, and then that's completely native completely native in C++, no external libraries, all written so that you don't have to worry about like importing the packet DLL from WinPCAP. And then also kernel mode, which obviously gives you full rights over the entire network stack and gives you the ability to do full packet capture, the injection part, interface with Indes, and some of the network monitoring that you would like want to see in a full feature RAT. So just a quick cover of how I went about doing this. Something new to this side is that, as I said, it's in C++, so we have to have a deployment method. My choice was Reflective Dll, just because of the portability of it. It makes for easy integration with other tool sets, like Cobalt Strike. Just had a question. Does anybody actually use Cobalt Strike here? Okay, so we seem to use it. We were using it heavy on our team. It has the ability to do reflective DLL injection, so there's your modularity right there. You have the ability to expand a RAT without recoding the entire thing. So in this case, we're going to go through starting the capture, building an Ipc thread, talking to that remote process, and we're talking to that reflective DLL injected into that process space. So you can't just capture the output of that. You can't just talk to it. Once it's like you create that remote thread, it's gone. It's like shellcode injection. You basically have no way of talking to it after that. So you have to have some type of like IPC communication with it. And then building the PCAP, receiving the actual data, filtering it, and then obviously writing it to disk. So the WinSock process is is a little bit complicated, but it's also pretty simple, like in the retrospect of things. Finding the documentation for this stuff is quite complicated though. So the cool thing is I put together, now there's a lot of bullets here and stuff of that sort. I wouldn't really worry about those too much. They're just more or less for if anyone wants to come back and reference some of these like actions and why I did things, you can come back and take a look at, each step that I went through. So the Wsa Startup, which is the WinSock application handle you have to obtain, basically I'm obtaining 2.2, which is supported from Windows 95 all the way up into Windows 10, which makes it cross-platform, which is amazing if as a developer for when you're developing attack platforms and stuff of that sort. So once you do that, it's kind of like you would see in any other application. You create a socket, you bind to it, and in this case, you're only going to grab IP version 4 and above. So you're only going to grab layer 3 of the OSI model and above. Imagine. So you're not going to be able to get the Ethernet packets, and that's a limitation of a raw socket in Windows. So that's really important to note. You're not going to get full PCAP, and you're going to miss some things. But for the most part, you're going to get like all your HTTP and ICMP, all that kind of stuff, anything with IP protocol. And then the most important part is the WSI ACTL, which is actually telling, like a call into kernel, telling the WSA application to turn into promiscuous mode and setting that up. And that enables you to actually receive the IP version 4 packets. That's really cool. I didn't know about this before. I didn't think it was possible, but there's some interesting resources out there that are all spread out, text documents from like 1995, and you could kind of find these things. And then eventually receive, just like you would call, which is just a blocking function on obtaining the packet data. So then we talked about creating the Ipc thread. I chose to go with name pipes because I would be using them later on in the development cycle. So in this case, I use like a language agnostic way of going about it. So I create a name pipe, and then I could also communicate with those same name pipes in PowerShell. So however I get to communicate to that thread, I can make it happen. It gives you as an operator a lot of choices if it's something that's built into your RAT, if it's something that is also, compatible with PowerShell. Like there's tons of ways of going about it. So if you're in a restricted environment, it makes for easy work. And then finally, as I said before, a lot of the functions, all the filtering, all that stuff is native in C++ and built by hand with custom structs and that sort. That way, it's completely native. You don't have to include the libraries of the WinPCAP development package. So that makes it really easy for you to go and take all this conglomerate of code and kind of tweak it for what your requirements are. So in this case, it's just an example of all the couple of the structs I put together for building the PCAP headers and all that kind of stuff. Oops. So, and finally, how do we deploy this? We talked about this before. Reflective DLL injection. This stuff is really, really cool. And Stephen Fewer, the guy's, I don't know, he's like a prodigy, I guess. It's amazing. To have that type of, on your name to say that you built that type of attack platform is really cool. But so why Reflective DLL? Some of you might not know what Reflective DLLs are. It's the ability to load in memory a DLL. So traditionally, you have to load these things off a disk. You can't just generally load a PE. There's no call in the Windows API spectrum just to load a DLL from memory. It just doesn't work that way. And so you have to basically build a reflective loader. So that gives you a really big stealthy advantage. That allows you to load the libraries without registering to the PEB, the process environmental block, and also allows you to hide from an enumeration of the process itself, and it won't yield in the process modules. So that kind of gives you in-memory, stealthy, and it allows you to deploy it with ease because you don't have to worry about writing this DLL to disk. So you just protected yourself from potentially HIPs and all these other different antivirus solutions. It also allows for that modular design that we talked about before. DLL patching, all those kind of things are in tons of projects. Metasploit uses it. There's tons of projects that use this. But there's the kind of the basic of how it works. You basically obtain a byte array, shove it into memory. You read, write, execute the memory first, obviously. Shove in the code for the DLL. Obtain the offset for the DLL export. Create a remote thread in the process. This kind of probably reminds you, if you've done shellcode injection, it kind of reminds you of something of that sort. And then from that point on, you basically reflectively load functions that are needed for the thread itself. So finding kernel 32 DLL so that they can call those functions for the load library. And then finally, you can execute DLL main. And here's actually a quick demo of it actually taking place. And I think this time I'm going to just going to do that so I don't have to deal with that again. With the Reflective DLL package that you build, it automatically comes with inject.exe, which is awesome. So you can basically inject right into itself. It's for quick testing. In this case, I basically just ran the project. It started up the PCAP, started and built debug.pcap. At the top, PowerShell is actually talking with that Reflective DLL and starting the packet capture. At this point, I'm basically just capturing some network traffic. You can kind of see it grow where it's like 17 kilobytes at this point. I sent in a command to reset. So now it went back down to 0. And you basically can do all these types of different like posts. I guess like you wouldn't just want to throw this DLL up and then not being able to stop it. Like you could just have a box just crash itself by running PCAP for like entire life of the box being up. So that would be a problem. Like I said, that's why you have to have some type of thing like this. So then, right when you're done, whatever tool set you'd want to use, maybe you write a custom encoder to drop this to like an encrypted store, and that store could be later on decrypted, which is what Duku did with virtual file systems, and boom, you have full PCAP, just like you would see with Wireshark. The one thing that you're missing, if you notice, is the checksums for the Ethernet headers do not match up. And that is the only function that I did not get right with CRC32 because it requires a secondary function. I just haven't gotten to it. But if someone wants to help with that, that'd be amazing. And that is how you do the Win PCAP. And this is really cool. This all led to basically driver loading at the end of the day. One of the main things that I wanted to do was being able to deploy WinPCAP and have that ability in a red team environment to deploy a package that could be all self-contained and actually execute this code. So that leading into kind of like why would I want to be going about this? Well, one, critical design, like we were talking about before, Duku has a ton of platform-like capabilities, right? So they need like these helper capabilities of loading drivers, like traditional signed drivers, of course. You can't get into kernel mode without having like a signed driver if you didn't know that. So, I mean, there's still like legitimate functionality, but there's different ways of going about it. Like we're going to cover both. There's like a service creation, where you can use SC to create a driver, or you can use NT-load driver to get it in the kernel space. So we're going to cover both of those, and somehow like how this capability can kind of integrate into your red team testing methodology. And finally, unsigned drivers. This is something like not a lot of people are talking about, but it actually just popped up in Project Sarin, and they actually used a vulnerable driver to get code execution in kernel space, and then was able to move their unsigned NPFF driver with the modification driver for WinPCAP into a kernel space and get code execution that way. So that's really cool. It shows you that just because you have the latest patches, whatever it may be, if they get system and they can drop a vulnerable kernel module, which getting system is not hard, any privilege escalation will get you there, and it happens quite often. You basically get into kernel mode without too much of an issue, because those code signing certs are good for that driver, and there's nothing you can do about it at that point. Currently, or you could just revoke the whole driver, but then you would break tons of like back compatibility. So, like I like to start out with every other capability I kind of built. Like, why would I want to do this? And I think, one, it's really cool to have full packet capture and the ability to potentially build like a WPAD, like attack platform with Reflective DLL. And two, because, building like direct replication is pretty cool. And so that's kind of why. The two methods that we talked about before, SC driver loading, that's using the service controller manager to basically start and stop the kernel driver, and basically you go through a small little set of events to make this happen. It's not complicated. It's easy to implement. It's dirty though. It leaves behind a lot of artifacts. It's a service creation. It's registry edits. It's everything that happens from the time of loading, and also requires it requires you to basically drop your path known to the service controller. So like if somebody were to look at it and see evil driver.sys or whatever, they're going to know that it's basically loaded. And then finally the NT load driver, which is an undocumented Windows functionality, which actually is being used by SC driver loading to load that driver from user space into kernel memory. And this allows for the full NDES application that we've been talking about with WinPCAP. So how do I go about building the SC driver? Building the SC driver version first. The first thing I had to do was obviously I had to come up with a way to weaponizing it. We talked about Reflective Dll, so I just kept with this through the entire talk. Weaponized it, wrapped it into Reflective Dll. It basically decodes a large base64 char array and drops the required files to disk. Opens SC Manager, creates a service, deletes a service, starts the application that's required for whatever PCAP or user mode application you're going to run, and then cleans up after itself. So just a little background knowledge on WinPCAP, what's actually happening. There's quite a bit of layers of abstraction that are taking place to get you into that point where you're actually going to be interacting with the kernel. Like I said, the packets are coming in. HAL's abstracting it through SDIO interface between the NIC driver. Then the NDS interface itself, which is like the networking portion of the stack, basically talks with the NDS protocol drivers, which interfaces with the upper edge of kernel space, which is the NPF driver. And then from there, you have to require to have two different DLLs that are on disk in the System32 path, which are Packet DLL and WPCAP DLL. Packet DLL does all your driver communications, and then WPCAP abstracts all those with API calls for easy application code execution. Something interesting is it's quite complicated, as in every single OS has a different type of DLL and different type of driver depending on architecture. So if you actually go and extract the MSI package that does the installer, you could tell there's 5 different DLLs for Packet. WPCAP has 2, 3 different drivers. So I've only tested on x86 7, 10, and 64. So those are the required ones just for the matrix. If someone wants to fill in the rest and go do the testing, that'd be great. There's probably a lot of operating systems that need to be tested and figuring out which ones are dropped. As for the service creation, as I said before, not all of it's relevant particularly to you, but if you ever want to go re-implicate this is the kind of stuff you need. You need to be able to open the SC Manager with all access, giving full privileges to the SC Manager. You need to basically create a service. You need to have it set as a service kernel driver, and then you basically need to have it on start demand, which is manual start. You can basically set it up to start the service, control the service, so you're basically setting it a stop signal, and then finally deleting the service. And this is actually the demo. So first thing I do, check for NPFF driver, not loaded yet. We're going to actually go ahead and I built these 3 applications that basically do like an interface listing using the WinPCAP libraries, all compiled, all set up for you. So if you want the Visual Studio packages, they're all there, easy to use, and easy to deploy. So I'm basically going to set it up as MS kernel service. I'm going to go ahead and inject that Reflective DLL and try to get those 3, the driver set up and the 2 DLLs drop the disk. So once I know I'm good from the debug messages, which you can just remove if you wanted to, obviously. I probably wouldn't leave them in there. I'm going to go ahead and do a driver query to make sure that it's actually been loaded and at the correct name. So even though it's network packet filtering driver, you can set the service query as a different name. So it sets the registry keys as those. So it kind of gives you a little bit of ease there setting those up, which is kind of nice. You can just name whatever you want to. That way, if somebody's actually doing driver monitoring, they would see that instead. At this point, I'm basically going to get the interface Once I have the interface good for that, I'm going to send it to the packet dump, which is just actually a built-in example package that you can get with the WinPCAP driver collection, and send it the device and actually collect right from the box. And that's from going from no driver to obviously full packet capture, which is, I think, is pretty cool. And finally, the NT driver driver loading with the Reflective DLL as well. So this one's a little bit different. You're actually calling it undocumented functionality. This one took quite a bit to get right. There's just not a lot of resources out there. Obviously, it's undocumented. It's not supposed to be used this way. These are functions that are being called on the back end that you generally, as a operating with the Win32 subsystem, would not be able to call. So the first thing I had to do was basically enable privileges. If anybody's ever looked at malware, the first thing it probably does is sets up every privilege it can possibly imagine, just runs those SE debug privileges, probably the first one, just so you can do process injection, all that kind of stuff. So I basically need SE driver load privileges. I need to go ahead and write the register keys that we talked about. Actually find NTDLL, get the handle to it, run the command, and then finally unload the driver with the same exact the function. So this is kind of like a step-by-step. The code is not too complicated, but the first thing you're going to do is enable those privileges like I talked about. Obviously, you're doing it locally to the process that you're in. So you just open a handle to your process. You obtain the process token. You adjust the token privilege, and then you send it the privilege that you want to load up. So once you obtain that and you're good to go, you have the right admin rights on the boxes. They're all in high context, obviously. You create the registry keys that you're required for the services, the system path, system type, service start, and the error control, which are just dword values and a bin path, basically, that you would pass to a service creation, the service creation manager. And then you actually go down to the next step, which is loading the driver. The first thing you have to do is you can't just include the NTF. I think there's one example out there that does it. None of the examples on the internet right now compile. You can't find an example that compiles with actually doing this function. So what I found out is you have to actually get the module handle for NTDLL. Then you have to get the proc address, which are pointers to NT load, onload, and the Unicode string. Then you pass the subkey that you just created to the Unicode function, which then gives you a pointer to a char array of your actual your stringed path, and then you can pass that to NT load driver, which then loads the driver and returns an NT status of 0 if complete, and if it doesn't, it passes some numbers that I have no idea what they do. Probably we'll never figure it out either. So, as I talked about before, there's some of the code. I'm going to be loading it as evil driver, just so you kind of have an idea of the registry key I'm creating. I'm going to go ahead and use the same exact method that we used before, which is the service creation the inject DLL for weaponization. Once the driver is loaded, as you can see, basically I'm just going to do a quick driver query to make sure the driver actually made it into the kernel mode. I'm just going to quickly search for it just to prove that it actually worked. Nothing too fancy happening here. And then obviously once you have this all set up, you can go about the same exact way as you would before with anything else. So you could do on the PCAP or whatever you need to do. So this could be an individual module that does the loading of the driver, and then you can reflectively inject another driver that does all the PCAP stuff. So that's the NT loader method, and that is all this is gonna be open source. So if you want to go check it out, use it, fork it, whatever you got to do, and it's all already pre-built with the Reflective DLL project. So everything's almost near weaponization ready. And I think we're getting close. last 10 minutes here. And finally, APT 29. So as the last group we're going to be looking at, they have a unique, basically a unique set of skills that's pretty cool. There's been a lot of research on these guys, and they have some crazy stuff out there. If you've ever read like hammer toss and some of the methods that they use to do C2 is just crazy. They'll use anything and everything, which make them really hard to hunt down. So, what makes them kind of special? One, WMI. If you've ever read anything about them, they utilize WMI heavy. And as somebody that's been getting deeper and deeper into the internals, I wanted to like replicate some of that ability with C++, which like you probably think is pretty daunting, and it absolutely is. Like something in PowerShell, it's extremely easy. You get WMI object and you're rocking and rolling. And with that in mind, they use a lot of PowerShell, so it makes sense for them to use a lot of WMI. It's easy to integrate. You shell the script I built before. Yes, it's big, a lot of objects, but it's easy to use. Like the return types are easy to pass, properties, the pipeline. It makes like life so easy. And then finally, the knowns about them. They've had people talk about them before. Mandiant's talk on like basically hunting these guys down is insane. If you haven't watched it, it's like from ShmooCon. I got to see it live. It was really cool. And then obviously Matt Graber has, and some of his buddies have a talk on why am I so sexy. So they're definitely good talks if you haven't looked at them. Like kind of like deeper diving into WMI operations themselves. And then persistence, not agent persistence, not like where I'm going to store, but these guys are well equipped, and they're producing samples by the day. Like if you listen to this talk, it's inspiring. Like these guys are generating 10 samples like a week pretty much, and one of them is completely different than the rest of them. So as you can imagine, the RE efforts to like figure these guys out, figure out where they are, and like get rid of these guys out of your network is insane. And then finally, agent development, which is something I'm going to move into next, and something that they do well. Multiple IOCs make it really hard to hunt them down, and it makes them be able to persist in a network long term. If your only RAT is Cobalt Strike and that's all you have developed, once it's burnt, you're burnt. It's done. But if you're using like backup agents, just like you would think C2 structure, if you're going to build C2 structure for your command and control, you're going to have a initial phishing access server, a operational server, and then a long-term or a long-haul server for your backup. They do the same thing with their malware. So I wanted to build like a long-term agent. It's really POC at the moment, but it has a lot of really cool stuff in it that I think that people would love to see and have examples on. Some of the stuff out there, like there's some code out there, but I have it all in one good place for anybody who wants to take a look at it. Basically, the entire agent itself is built. The shell is built. It's in pure C++, in-memory logging, obfuscation of all the strings, standard calls for everything you'd like want to see in an agent, like sleeping, jitter, all those basic stuff, VM detection, AV detection, some using WMI, some using the standard API calls, and process listings, shell commands, the whole shebang, everything that you'd want in a standard agent. And then since it's a long-term agent, the only thing I really needed was some method of getting secondary code access or code execution. So I built in full shell code injection and process injection with the token manipulation stuff. So if you actually wanted to go look at this code and have like, see actual running code, it's all there. Because a lot of the stuff, like you can get a peek into it, like Hacking Team dump and stuff. They have some dumps out there. Some of them might be complicated. A lot of the comments are all in like, French or wherever, there's tons of different languages like that are operating on that code base. And eventually the coolest part, WMI monitoring, which is something that the defensive side is using heavy. Service creation, process creation, and driver loading. So why should I care about those type of things? If you're a hunt and IR guy, like that's like bread and butter right now. The ability to go and detect these kind of things, are priceless. Things like Uproot, which is built by Jared Axon. I got caught on an op, like a training op with that and with my pants down. So it sucks when you get caught by these type of things, but it makes you like think as like an attacker, what can I do to like detect them doing this back to me? So think about how you capture memory from a compromised machine that you as like an IR guy. You're going to bring over your USB stick with Memorize on it from Mandiant, and you're going to plug that thing in. You're going to get a kernel mode dump onto the USB stick, and you're going to take it back. But when you plug that in, you have some risks that you're obtaining, like you're plugging a USB drive in. You have to load a kernel module or a kernel driver into kernel space to get that kernel memory dump. So, as an operator, these are things you need to think of. And all those kind of things lead into like service creation, like Cylance. If you read the OPM reports, if they were to detect the service creation of Cylance being created or installed on the systems, maybe the hackers at OPM would not have gotten caught. Just thought, because they got caught, according to the report, by keystroke logging. And eventually, like, driver creation, all those kind of things that you want to see. So, I don't have much time, so I'm going to pound through this. Basically, the core agent has 3 different threads that do all the collection, pushes it into a monitoring thread, which then has a JSON array, a vector of JSON array rules that are then basically have like agent panic modes that are set. So here is actually a rule creation taking place. On the left side, you have an actual JSON rule, like detecting, let's say, Wireshark.exe or the executable path has Wireshark in it, and then it has panic settings for sleep, exit the agent true, and report the trigger. Obviously, if you get caught by Wireshark, you'd probably want to stop all like communication. So I had false. So all those type of like granular things you can set up, and then you eventually have a rule trigger handler, which then handles like zeroing out the agent, cleaning your heap, and doing things like that, so that if you get caught and you do have, they don't know how. Like one thing that as like analysts, you want to know how far they got, right? So if they have my memory logging outlet and they can detect it, well, they might just know everything I did. But if I can get rid of that first, and they got my agent, not too big of a deal. And then finally, here's actually a process creation event taking place on the command line. A service creation event. As you can see, like this is the path name of creating a Windows System 32 cmd.exe service that would spawn a service at a given time. And then finally, a rule triggered, which actually is inside the agent. So I'm just going to do a quick demo on this. I think I have enough time. I'm really close, but I think it's about a minute or two. So I have a POC handler. Anybody knows anything about the Empire side, I'll actually be trying to integrate this with Empire eventually, or the universal controller will be coming out soon. And this will give me the ability to actually like use this on a usability scale. Like right now, it has all the core agents built. Everything's there. As you can see, it actually just received a command to do a run a shell command, which was a dir. And on the other side, it's just receiving the output. So anything like you would see on a normal like agent handler, you have that ability. It's all there for you using the cryptological APIs that are built into Windows, all the encryption, base64, it's all built there. It just needs the core orchestrator handler now. Right there, you just kind of saw an example of process monitoring taking place inside the agent itself. And it's just kind of set up to print to the screen right now just for aesthetics. So you can see the task list.exe executed, and then also with the command line arguments, the process name, the event type, where it came from, the path, all that type of stuff. So you got really granular activity. Here's a service creation that we talked about before. It's an event filter set for like every second. So basically, I can receive all that stuff for service creation, all the fancy stuff. And this allows me to do that type of post-processing of the actual IR functions taking place on the box and respond accordingly. It gives the agent itself, it gives it leverage to the operator that they could not do situational awareness and give it like at 12 o'clock at night. So things that like you would generally do your safety checks when you get on a box, you might not be able to do at 12 o'clock at night, or that might be sleeping for a day at a time. That agent has to have some type of capability in the back end to survive. And this is kind of what I built. So in that case, it monitored a Wireshark ping, and it triggered an execution, and it basically exited the agent. And that is the WMI monitoring agent. And finally, the last slides. Key takeaways. All the techniques talked about are kind of like, they're used and, they've been talked about. They're documented. Some of them are well documented. Some of them are not. Hopefully the mass amount of C++ and PowerShell code I put together helps somebody. All of them are written in Visual Studio 2015 on a Windows 10 updated image, and all compile perfectly. That's like, I don't think, like, if you were to go looking for some of this stuff, getting something that will compile is literally the hardest thing you can imagine. Like, it's insane. Like, unless you're looking at some forms from, like, the 90s. That's about it. Some of the key takeaways, obviously, the techniques and the TTPs are awesome, really awesome to kind of integrate, kind of show off, some of the, like the team's prowess and all that kind of stuff. So I think overall, it was a great experience. I got to learn a lot about coding, got to learn a lot on a low level, operational level, that stuff that as an operator you can debug issues even if you have like a paid tool set. And finally, all the code is going to be open sourced, and it can be all found on my GitHub at Killswitch Tech GUI. There's basically just a list if somebody wants to take a look at them later. Any questions? Yeah. No questions? Okay. Thank you.